Hi class, in this video we are going to learn about salt analysis. So we are still in chapter 7.1 and learning outcome H. Explain qualitatively the salt hydrolysis using hydrolysis equation and classify the salt form from the reactions between strong acid and strong base, strong acid and weak acid and strong base. So you need to identify what is your reactants and what is your salt form. So first of all, you need to know that a salt is produced from a neutralization reactions between acid and base. And the salt produced will dissociate completely into its cation and anions. So when we say dissociate completely, we will use a single-headed arrow. So for example, if you have the NaCl salt produced, okay, so this NaCl salt will dissociate completely to form Na positive, the cation, and Cl negative, the anion. Okay, so dissociate completely for a salt, we are using a single-headed arrow. So salt hydrolysis is the reactions between cation or anion from the salt with water to form either hydronium ion or hydroxide ion. So the word hydrolysis itself refer that this is a reactions with water. Okay, so the product from the salt react with water. And the pH value will depend whether you are producing the H3O plus or the OH minus during salt hydrolysis. If you have strong acid or strong base, the ion from this strong species, okay, does not hydrolyze with water. That means it will not undergo salt hydrolysis. Therefore, you need to apply auto-ionizations of water. Auto-ionizations of water, you have learned about this one before, which we use the H2O liquid, and then it is in equilibrium with its cation and anion, so which is H plus and OH minus. So this equation refers to this auto-ionizations of water. So same thing, we just add one more molecule of H2O liquid and then in equilibrium to produce your hydronium aqueous ion. So remember that H plus and H3O plus, they are similar depending how do you write your equation. So there are three types of salt, depends on what is the acid and base that you're using. So you need to take notes on all the examples of the strong acid, strong base, weak acid, weak base. So first, if you produce an acidic salt, it will be produced from the neutralization reactions between a strong acid with a weak base. So given in the examples here, you have a weak base ammonia hydroxide, NH4OH. So when you react with the strong acid HCl, you are producing this NH4Cl acidic salt. So this NH4 positive comes from the weak base, combined with the CnCl minus from the strong acid to give you the acidic salt. Second, you will have the neutral salt, which is produced from the combinations of strong acid and strong base. So a very common example, NaOH, strong base, HCl, strong acid. So combining the cation from strong base, anion from strong acid to give you this NaCl neutral salt. And lastly, we have our basic salt, which is combined between a weak acid and a strong base. So giving the examples over here, strong base NaOH. So combined with a weak acid CH3COO3. So Na positive from the strong base combined with the CH3COO minus from your weak acid to give you a basic salt. Okay, so let's look at the type of neutral salt, which is the product from the reactions between a strong base and a strong acid. So first of all, you need to write down the neutralizations equation. So strong base NaOH and strong acid HCl to produce NaCl aqueous solution and also water liquid. Then after you have identified your salt, so in this case, the salt is this NaCl. So we need to write the equation for its complete dissociation. So we are using NaCl aqueous. Remember that dissociation is complete, so single arrow. And you will get Na positive aqueous ion and Cl negative aqueous. Why we are writing aqueous? Because now it's in solution. In this solution, we have Na positive, the cation, and a Cl negative, the anion. So the Na positive is a cation from a strong base NaOH. So remember that strong acid, strong base will produce cation and anion that will not be hydrolyzed in water. So therefore, Na positive does not hydrolyze in water. Similarly, Cl minus is the anion producing from a strong acid. So Cl negative does not hydrolyze in water. So both Na positive, Cl negative does not hydrolyze. Therefore, we need to use this auto-ionizations of water. pH value will depends on the auto-ionizations of water. And come up with this equation. H2O liquid in equilibrium with its product H plus aqueous plus this OH minus aqueous. So since the concentration is similar like our calculations previously, as the ion product of water Kw is equals to 1 times 10 to the power of negative 40. Therefore, the concentrations of H plus or H3O plus is the same as OH minus, and then it is the same as 1 times 10 to the power of negative 7. Same concentrations give you the pH value equals to 7. If you want to, you can also fill in or substitute the values to give you a pH 7. Okay, therefore we can say that NaCl is a neutral salt. So NaCl is come from the terms that Madam highlighted earlier here. And you need to make a conclusion. Based on this auto-ionizations of water, NaCl is a neutral salt. Alright, next let's look at the acidic salt. So acidic salt is produced from a reactions between strong acid and weak base. So given the examples over here, you have the strong acid HCl and the weak base NH3. So the neutralization equation goes this way. HCl and H3 react to give you NH4Cl. So remember that a base will accept proton and acid will donate proton. So you are producing this ammonium chloride salt. Since the equation is already balanced, then therefore there is no H2O in this equation. So the one that Madam highlight over here is the salt produced. So after you got your salt, you need to draw an equation that represents the complete dissociation of salt. So NH4Cl will completely dissociate to give you NH4 positive and Cl negative. Alright, so the first ion producing over here, we have our NH4 positive. So NH4 positive is the conjugate acid of a weak base. Recall that NH3 after accepting a proton, okay, it will become a conjugate acid NH4 plus. For this NH4 plus, since it is the conjugate pair of a weak base, it can be hydrolyzed in water. Alright, take notes on over the green box over here. Conjugate acid or conjugate base of a weak species, weak base or weak acid, can be hydrolyzed in water. Therefore, we were using the hydrolysis equation of the conjugate species. And then in the second point over here, the second ion you get from this dissociation is Cl minus. So still, Cl minus is from a strong species, so it will not hydrolyze in water. Since you have your conjugate acid, therefore we are doing the hydrolysis of this conjugate acid. So in this case, the conjugate species is NH4 positive. It will react with water, H2O liquid, Hydrolysis is an equilibrium process. So it will producing NH3 aqueous. Okay, why NH3? Look over here. NH4 positive is an acid. An acid will donate its proton. So after removing the H plus, you get an NH3. So of course, H2O in this case behave as a base. A base will accept proton. Okay, they are just changing partner. They are just changing the partner of proton. Okay, so this is the hydrolysis equations of your conjugate acid NH4+. So in this equation, you can see that after the hydrolysis of NH4 positive, you got an H3O plus in the equation. So hydrolysis of NH4 plus produces the hydronium ion. So we know that if you have more H3O plus or H plus, it means that your pH value is less than 7. Okay, since H plus refers to an acidic solution. Therefore, we can say that NH4Cl, the salt you formed earlier, is an acidic salt. So this is the explanation. You will have 3 equations altogether. Neutralizations, complete dissociation of salt, and one more is the hydrolysis equation. Alright, last one. If you have a basic salt. Basic salt is produced from the reactions between weak acid and a strong base. So giving examples over here, CH3COOH, your weak acid, and the strong base NaOH. So neutralizations equations, it will produce a salt CH3COONA and H2O liquid. So this is the salt that we are going to interpret and analyze. So complete dissociation of the salt CH3COONA aqueous will dissociate completely to give you CH3COO negative and Na positive. Okay, so which one is the cation of a strong base NaOH? So obviously, Na positive is the strong base. Okay, it's dissociate from the strong base. Anything from the strong base will not react with water. On the other side, another ion dissociate from the salt is this CH3COO negative. This is a conjugate base of a weak acid. Remember that an acid will donate proton. So after CH3COO H donate its proton, it becomes the conjugate base CH3COO minus. This conjugate base can be hydrolyzed in water. Therefore, we are writing the hydrolysis equation of the conjugate base. So CH3COO negative, the ion, the conjugate base, react with water. Again, it will be in equilibrium to produce CH3COOH. So CH3COO negative will accept the proton to become CH3COOH. So this is the aqueous solution. And then the H2O will donate or give away the protons to the conjugate base. So anyway, you need to make sure the whole equation is balanced. We are just changing the partner of protons only. So in this hydrolysis equation, you can see that there is OH negative in the equation in the product side. Therefore, we know that this should be a basic solution. So make your conclusion. Hydrolysis of the conjugate base CH3COO negative produce OH minus. Therefore, pH value is supposed to be greater than 7. And we can say that CH3COONA, sodium ethanoate salt, is a basic salt. So again, there is 3 equations. Equation for neutralization, equation for dissociations of the salt, the equation for the hydrolysis. Alright, so after the explanations and the examples given, please try your exercise 3. There's only 2 questions over here, especially for your question number 2, which may give you different combinations between strong and strong, strong and weak, weak and strong. You need to recognize the examples. So over here, Madam will explain one of the examples given here, which is NaClO. So in this question number 2, it asks that write the hydrolysis equations for the following salt and classify them as acidic, basic, or neutral salt. So in this questions 2F, questions have already given you the formula of salt. Therefore, you can exclude the first equation, which is the neutralization equation. So we straight away into the complete dissociations of the salt. So NaClO, this is a salt, undergoes complete dissociations to give you Na positive and ClO negative. So you need to recognize from here. Okay, Na positive is come from NaOH, which is your strong base. So remember, any strong species, doesn't matter strong acid or strong base, the ion that form from strong species will not undergo hydrolysis. Also meaning that it will not react with water. But then if you look at this ClO negative, it is actually come from HClO, which is a weak acid. So anything dissociate from weak acid, it will undergo hydrolysis. Okay, so anything from the weak species, for example, conjugate base of a weak acid or conjugate acid of a weak base. So they will react with water and undergo hydrolysis. So we are using the one that can undergo hydrolysis. In this case, is your ClO negative to do the hydrolysis process. So ClO negative will react with water, and then in this process is in equilibrium. So ClO negative will accept one proton from the H2O to become HClO aqueous solution. So the H2O, after removing one proton, it left with OH minus. So you can see over here, the proton is transferred from the water H2O to the conjugate base. So you may do your explanations over here. ClO negative is the conjugate base of a weak acid. Okay, so hydrolysis of ClO negative will produce OH minus, which in this case, you refer to the OH minus of the hydrolysis equation. So pH values is greater than 7, therefore NaClO is a basic salt. So there is 2 equations involving over here. And you may try to practice writing down the sentence.